All right, for this presentation in the education series, we will walk through a sample GeneSight report. So the objective for this presentation, as I had said, is to review a sample patient GeneSight report. And as we go through the sample report, there will be a couple of instances where I will interpret the specific results of this patient's pharmacogenetic results and explain how they may impact practice. So this is the first page that you'll see for a GeneSight psychotropic pharmacogenomic test. So this is the report for a sample patient. You'll see your patient's name and date of birth in that top left corner. And then these reports are very nicely color coordinated. So you have a green section, use as directed. It gives you the generic and the brand name. And then you have a moderate and significant gene-drug interaction section. And each part of the report, it's all separated out into specific classes within the class of psychotropic medications. So for example, this first section is the antidepressant section. And then you'll see these numbers next to the drug names, and this corresponds with a key that will be visible on our next slide that gives you some idea of why each of these drugs is in that particular category, very similar to the icons that are available in the 1-ohm reports. So each section will have its own clinical considerations key section. It'll go 1 through whatever number is relevant for that particular subclass. And in this case, as you can see, 5 and 7 are eliminated because they just don't apply to any of the medications in this particular patient's report for the antidepressant section. And then there are a number of different clinical considerations that can be considered. And so I just wanted to point that out, that each section is going to have a key, but theoretically, number 1 should be the same for all subclasses. They may just not all be listed at the bottom of each section. There are additional sections for anxiolytics and hypnotics, antipsychotics, and mood stabilizers, and they will all have that same green, yellow, and red categorization and the clinical consideration numerical value assigned to each drug in the yellow and red sections. And then for further explaining each genotype and phenotype, the report is separated into more of the pharmacodynamic genes versus pharmacokinetic genes. And the pharmacokinetic genes are typically more related to metabolism. Pharmacodynamic genes have a lot more to do with transporter genes or other genes that are known to precipitate potential adverse drug reactions. And so if you look, it is separated out as the bold is this particular gene, then you're looking at the genotype, and then this is the phenotype. And then they all have a short little paragraph underneath them to explain what this means for this particular patient. And so the next section is the pharmacokinetic gene section, and as I mentioned, usually this has a lot more to do with metabolization of the medications. And so it's set up in the same way where you have the gene, then the genotype, and then the phenotype, and then you have that short description below it that is specific to this patient's phenotype. And it pays special attention in this patient report to the CYP2C19 status. This one is an ultra-rapid metabolizer status, which demonstrates increased activity, which means that in the case of a prodrug, you're going to have a higher turnover into the active drug and a higher risk of toxicity or adverse effects. And then on the other side of it, if you have an active drug, this is going to metabolize it much more quickly to its inactive form and therefore likely not be as effective for this patient. And then the other one I want you to pay close attention to is the CYP2D6. So this is a poor metabolizer phenotype. And so this is the opposite of what I had said before. And in this case, a prodrug that is metabolized by CYP2D6 would not be as effective, and an active drug is more likely to cause more significant toxicity or adverse effects in this patient when used at typical doses. And then this is probably the best part of the GeneSight sample reports, is that they each have sections for the gene-drug interactions. So they'll separate it out into the green, yellow, and the red, and what that means. So in this particular case, if you look, this says to use as directed. And so if we come down to paliperidone, and why I wanted you to remember the metabolizer status for CYP2C19 and 2D6 is because this patient has that variant in CYP2D6. And therefore, you would think that therefore we would be worried about using paliperidone in this patient given that potential gene-drug interaction. However, it's also metabolized by CYP3A4, which is also a major pathway of metabolism, and therefore we don't really have to worry in this case given that all of the information that we have on this drug and with this particular phenotype and genotype that this patient is expressing, that we would be able to use these products and this particular antipsychotic as directed. And then in the following section, you'll also see this for the more major gene-drug interaction. It'll be a red title for that particular section. But this one is the moderate gene-drug interaction. And I want you to take a look at the citalopram because this patient has the ultra-rapid phenotype for CYP2C19 and the poor metabolizer phenotype for CYP2D6. And so in this case, you have these two pathways that are sort of competing with one another. One results in increased metabolism, one results in decreased metabolism. And it's a little difficult to determine exactly to what extent these may or may not cancel each other out. And this is when using our resources is very helpful to determine whether we are more concerned with the CYP2C19 part or the CYP2D6. And so if you go and you look up citalopram and the metabolism pathway in PharmGKB, sometimes you can get a little bit of information as to what percentage of the drug is metabolized by each of these particular enzymes that are responsible for metabolism. And that may give you a little bit of an idea of how to start dosing. Another thing that I would probably do, and a number of people who work in pharmacogenomics would agree, is that you start with a dose that seems reasonable, and you see how the patient responds, and then that will kind of give you a little bit of an idea as to which of these phenotypes is outcompeting the other. So those are the major components of looking through a GeneSight report. I hope that this was really helpful. Thank you so much for listening. Again, please reach out via email if you have any questions about the material. And remember to rely on your resources to answer any questions that you may have about each of your patient-specific reports. And as time goes on, you're going to become more and more comfortable with interpreting these reports and what each section means. It's really important that you understand it yourself in order to explain it to your patients. So again, please reach out if you have any questions. Thanks.